That should be working now. There we go.
Yes, I can see you and I can hear you clearly. And I will share your presentation from my end. Just give me 1 minute.
Yeah, that's great. Thanks for doing that.
No worries.
Unfortunately, I'm not allowed to share on either my laptop or my iPad to Zoom. So, okay, well, thank you very much, everybody. Great to be with you this afternoon, and thanks for that introduction, Phoenix. Yeah, the topic this afternoon is large-scale testing of infrastructure for repurposing of hydrogen, and this is really an iteration from anybody that has seen my previous presentation that I did with Prospero last year. We've been moving on quite significantly in our work, and we're getting into some of the detail now about how we might look at repurposing the assets. So starting to look at the physical trials we might want to be doing, actually how we might make that happen in the real world. And I'm going to say a little bit at the end there around how we might start working with blending of hydrogen and what our thoughts are around that. So if you just move me on to the next slide, please, Phoenix. I'm going to begin by just giving an overview, really, of some of the challenges of transitioning a current asset base. So just to put it into perspective, we've got 7,500 kilometres of high-pressure gas main. That supplies about 3/4 of Great Britain's energy today. It's about 895 terawatt hours of energy per year. So it's a very critical national asset. So actually, how do you go about moving that from carrying natural gas, and in places it's been carrying that natural gas for 50 years, and start moving that to hydrogen? And you'll see from my slide here, very obviously, it is all about how do we manage the safety. That you can look at all of the aspects about the how and how you might pay for it and everything. But if we cannot demonstrate we can't do this safely, then we just can't move forward. So my biggest number one challenge is very much around the safety aspects, and it's really about understanding how compatible are the assets we've got today and how could they be utilized in the future. So looking down the challenges side of the screen here, we're very interested in obviously the materials compatibility. We're interested in what evidence base have we got. Bearing in mind, you could go to a supplier today and probably buy an asset that could do this for us. We're trying to look at how an asset that we potentially bought 50 years ago can do this for us. With every best will in the world, assets that have been in the ground for 50 years, the data we hold about them might not be completely adequate for the purposes of a hydrogen transition. They've been working in a natural gas environment for many, many years. We've got the maintenance records around all of that. But do we have all of the information we need to know for a hydrogen assessment? And then, of course, we've got to make the whole thing work from a network management point of view. So starting to look at how we might mitigate some of that. The main program of work that we're embarking on now is called Future Grid. It's around asset testing, and I'm going to spend quite a bit of time dipping into that in a moment. But the rest of our work is very much about data acquisition. That's data that we can acquire ourselves from our own network, from our suppliers, or from others. And that's really where the collaboration aspects come in. So I'll say a little bit about that. This is an area that we really can't solve these problems on our own. It's also one of the reasons why you see us out at a number of conferences around the world, talking about what we're doing, but also offering that outreach to talk to others around the world that may have similar assets, because we're being very open in our testing and our approaches, and equally we'd like others to do the same and share that information with us. That obviously helps overall then, because the cost of working some of this out is huge. And at the end of the day, we've got to develop the cost benefit analysis and moving forward, and we've got to do all of that network and financial modeling. So there's an awful lot to do, and we've been on quite a journey. If you can just move me across to the next slide, please, Phoenix. This is quite a useful slide that shows the sort of increasing of our asset learning over what is really, I'd say, the last 3 years. That's me down in the lower left-hand corner there, where I asked the fundamental question, can we actually put hydrogen into a transmission network? And that's quite an honest question I asked 3 years ago when I joined National Grid. There's lots of work been going on in distribution networks, looking at plastic networks, but what happens when you get a steel network that's been in the ground for many, many years? And we embarked on some internal research. We did some of the work ourselves. We also let some of the work out to the consulting division of our safety regulator in the UK, the Health and Safety Executive. And they came back with a piece of work for us that says, excuse me, yes, you can put hydrogen into your transmission network, but, and there were about 70 buts, there were about 70 items that we needed to go away and really understand and research. We've been busy on that agenda now for a number of years, and there's a number of ways in which we've been answering some of these questions. External research, some people might recognize there the Marco gas infographic. Excuse me. That was quite a useful piece of work gathered from a number of organizations that gave an idea about the suitability of hydrogen for assets. We've then done a very similar piece of work in-house, which was engaging with our suppliers. We went out and asked them, how suitable are the assets you've supplied to us in a hydrogen world? Obviously, we didn't get answers back from everybody. We weren't able to get a complete data set across all of our assets, but that data set that we got was very, very useful. And you see that in the middle infographic. Excuse me. We've since been working with the H2GAR group. H2GAR is a network of TSOs across Europe. We've got Snam, Energas, GRT Gas, Open Grid Europe, Fluxys and Snam all working together. We're sharing knowledge, sharing research, but also engaging with the market proactively together. So we'll have one conversation with a compressor OEM rather than having many conversations. And then we've also been in-house doing quite a bit of work around targeted vendor requests for information. So when we're going out to market, say to buy a valve for our current programs of work, we're also asking the vendors, how suitable are your assets for hydrogen? So that is starting to give us quite a bit more richness of information on the suitability of both current assets, but also how we might change our policies for purchasing in the future. So this has been quite a journey. Where that's really got us to now is the next step, and that's really to take things off the bench and take away the theoretical aspects of our knowledge learning and start putting it into practice. And this is where we've embarked on what we're calling Future Grid, which is our large-scale hydrogen test facility. And if you can just take me on to the next slide, please, Phoenix. This is an overview of the overall site. Now, some of you will have seen some of these pictures maybe before. In the foreground there, you've got High Street. Now, High Street are 3 hydrogen houses that have been constructed as part of a previous study. That's been done by Northern Gas Networks and Bays at the DNV-GL test site up in Spade Adam in the north of England. So those houses are constructed, they're in use. I was actually in one of those just last week because I visited the site. In the green area, just above H21, is a distribution network program of work. There is now a kilometre of distribution pipe in under that shaded area. It's actually in the ground already, and I need to get a new drone picture to reflect that. Also in place is now the high pressure gas reservoir in the yellow shaded area. That is a section of high pressure transmission pipe that we're using as the main storage vessel for hydrogen. It's about 50 or 60 meters long, very, very large, 4-foot diameter, 1200 millimeter diameter pipeline. What we're then intending to do is to build around the top end of the site. So that horseshoe that you see around the top end of the site is going to be the main Future Grid facility. And then we're reserving the area of land down the right-hand side there that comes to the foreground for a later extension. We want to be able to accommodate probably a couple of kilometers of high pressure gas main on this site to be able to run pipeline inspection gauges through it. But at the first phase, it's going to be at the north end of the site. It's going to be a loop of decommissioned assets. And by decommissioned assets, what I mean is these are assets that have been running natural gas for many years. They are real assets from our network. We are taking them out of service and we are bringing them in and putting them back into service as a hydrogen test facility. So if you can just move me on to the next slide, please, Phoenix. Hopefully these slides will start to bring it alive, because what we've got here is a schematic of I'll call it a loop. It is a loop. It's a very big loop when you're working with pipelines that are 3 feet or 900 millimeters in diameter, just to give you an idea of the scale of what we're going to be constructing here. So if we start at the top, we've had to go out and acquire ourselves an entry point. If you just bring up the animation, please, Phoenix. There's a picture there of the entry point that we're going to be bringing in. That has been in service for many, many years. It's no longer needed. The gas is no longer coming in at that point into our network. So what we're doing is we're decommissioning that, we're taking it apart, and we're bringing it into the site. To take the entry point and the exit point, there are probably about 10 to 12 heavy goods vehicle movements. So very large trucks that are going to be needed to bring this equipment into the site. And when we talk about bringing the entry point in, we mean all of the slam shut valves, the filters, the flow meters, the flow control valves, and any pig traps that we've got at that facility. It is the entire set of equipment. Within the pipeline facility, we'll have a number of block valves. If you just animate me again, please, Phoenix, to the block valve. We've got a number of block valves on our network. Some of them we're taking out. Many of you will be familiar with the block valve. If you're from the distribution world, you'll be used to small valves. Our valves, when they're on 900 millimeter main, are huge. They are very, very heavy. We're bringing a number of these in to the site. Animate me again, please, Phoenix, and we're bringing pipelines in as well. We're very fortunate in one sense. There is another major infrastructure program underway here in the UK to build a new high-speed rail line between London and Birmingham, and we're actually having to move some of our high-pressure gas mains. So this one was taken out just recently, not far from where I live. Very large section of pipeline, and we've been able to take that in, and we're utilising that in the facility. The idea with the pipelines is we will have a full representative sample of all of the grades of steel that we have in our pipeline network. So starting down in the X50s up to through the 60s, and hopefully up to the X80s. We have no X70, so we'll be up to X80 if we can locate a section of pipeline of X80 that we can actually bring into the site. But we want to make sure it's fully representative. And then finally, Phoenix, you can just take us down to the image of the exit point. This was lifted and shifted just a few weeks ago. If I had a bit longer in our talk, I would actually be able to show you the time-lapse photography of the takedown. It took about 3 days to completely disassemble this exit point. It used to feed a former chemical works. So that site is completely gone now. We've taken all of the pipeline infrastructure and all the buildings and the kiosks up to the site. So just to emphasize the sheer scale of what we're doing. So that's the main part of the loop. You'll see in the lower left-hand corner of the schematic, there's a connection then to the distribution network. And obviously then what we've got on one site is the transmission network feeding a distribution network, feeding houses. And that's a very, very key part of the value proposition of doing all of this testing. We're actually able to demonstrate an integrated network. So our partners on this project are Northern Gas Networks, because they're doing the distribution piece, DNVGL because they've constructed the hydrogen houses. So it's a very integrated program that we've got overall. We do have some other partners on the project, and in a moment I'll mention one of those, which is Fluxys. So just to complete the loop we've got here, there's a recompression rig. That's a small recompressor that will push the pressure back up and put it back into the high pressure reservoir. So essentially, for the majority of the time, hydrogen is just going to flow in circles around this high pressure facility. It's going to run at full transmission pressures up to 80 bar in our cases. And the testing will take place then probably in the second year of our program. We think it's going to take about a year to build all of this before we're fully up and running. So if you can just take me forward, please, onto the next slide, please, Phoenix. We'll just run through here some of the testing we're going to be doing. And this is just at a very high level. In broad principles, we're going to start the network at 2%. And that's largely to just check everything is functioning, see if we've got any seepage around valve seals and valve stems and so on. We then plan to take the network up to 20%. And that's the theoretical limit we can take hydrogen up to in a distribution network without swapping out any burners or boilers or furnaces, as they call it in the US, in people's homes. And we then intend to take that network up to 100% hydrogen. We also, apart from the main test and the main test facility, will have a number of standalone tests going on in addition to the main future grid facility. So these could be individual valves being tested, individual sections of pipe being tested. We're going to do some rupture testing. We're going to do some extended life testing under hydrogen conditions. So look at 150,000 pressure cycles on an asset, for example. We couldn't do that in the main circle of the facility, but we can do that in standalone tests running alongside. So the future grid is not just the main loop, it's also a number of supplementary tests that we're going to be running. Just want to pick up on the middle point on the slide there. All of this is about how do we actually get a level of understanding that we can extrapolate across our networks. And this is where our partnership with Fluxys comes in. Fluxys is the Belgian TSO. I would say their hydrogen program is probably more from an academic top-down point of view. Our program here is very much bottom-up from the assets. And actually, we realized some time ago it would be actually very beneficial to bring these two programs together. So we've developed a brilliant working relationship with the guys over at Fluxys. They're going to work on a fast screening methodology. They've got a great relationship with the University of Ghent in Belgium. And they're going to allow us to take some of those test results and provide that extrapolation across the wider parts of the network. So quite a cohesive test program here. We're very much at the start of the build process. There's a lot to do over the next 12 months while we actually commission this. And hopefully what I'm going to be able to do, if we had to do this conference again in sort of 6 months' time, we're actually going to be able to show you some of those assets starting to be in place and some of the commissioning processes that we're going to be going through. And some of those side tests will already be underway because we can actually accelerate those and get moving a lot quicker. Where we intend to get to with all of this is to deliver our initial vision of delivering a hydrogen backbone for the UK. And if Phoenix can just take me on to the next slide, this just explains I'll call it our rollout vision, our rollout project. We call it Project Union. And what we've got in the UK is a government strategy which is very led on both blue hydrogen with CCUS and green hydrogen. And what we're seeing is the major industrial clusters are very much leading on blue hydrogen. And these are marked up on the slide that you see here. So Grangemouth, Teesside, Humberside, Merseyside, South Wales and Southampton are the main industrial clusters. It's where we've got the largest levels of CO2 coming from industry. And the concept behind Project Union is to join those locations together with a transmission asset that is repurposed from our overall asset. Now, it's very easy to develop some colored lines on a PowerPoint, as you're seeing here. It looks quite easy. It's a lot harder when you're trying to unpick a network that is fully operational, has to maintain very high levels of service. Our levels of service are around 99.996%. So we can't just start taking assets out if we're going to reduce customer levels of service. So there's a sequencing we've got to work out here. There's a suitability of where we might have resilience and also the suitability of the assets. So we're currently doing a lot of modeling work around which pipelines could be taken out of service first and transitions to hydrogen. If you've got that transition to hydrogen, how much load do you move off the transmission network and onto the new hydrogen network? And does that give you then the headroom in order to be able to go after the next pipe? So we're working through that. We're using some very clever cloud-based optimization tools. This is taking your normal network modeling tools and taking them up a step. They're working 24/7 in the cloud. Since Christmas now, we've run about 1,200 scenarios of potential backbones across the UK. And we're starting to identify where our preferred routes might be. And what we've got to do then is start dipping into the detail of what data do we know about those assets? What assets are actually in there? Are they suitable for hydrogen? What's the feasibility of actually working with those individual pipelines between those locations? So there's an awful lot to do as we start working through the hydrogen backbone concepts. This ties in very, very nicely with the work of the European hydrogen backbone. And I know you had a presentation on that yesterday. The first version of the European hydrogen backbone we weren't a part of, but we actually published Project Union at exactly the same time within a couple of weeks. And it was very, very aligned, which was fantastic. So we've now joined the European hydrogen backbone project. If you just move the slide on, please, Phoenix, I've just popped this slide in, which just briefly summarizes the presentation you had yesterday. So the European hydrogen backbone study has gone from 11 TSOs to 23, and it's really ramped up the size of the potential network across Europe. The quantity of conversion versus new has dropped a bit in this latest version, but that's very biased around the pipelines that are up in Scandinavia there. You'll see from a UK point of view, we show a very heavy potential for conversion. That hides the fact that actually on this slide, we are showing sort of all potential options as solid lines. And it also hides the fact that we haven't actually worked out where some of those more strategic connections to some of those production locations are going to be needed in the future. So don't read into the fact that there's no yellow pipe on here, that we don't need any new build to connect all those dots or provide additional levels of resilience. That's all work to be done in the future. But the important point here is we've now got Europe. It's showing the connections using the interconnectors that run under the English Channel, connecting with Bacton in the UK. And you can also now see the connections running out of the UK into Ireland. So we've got the cohesive network that we enjoy and benefit from today, and we're able to demonstrate how that might work in a hydrogen future. So great to be a part of the European hydrogen backbone. We're learning a lot, and hopefully we're offering a lot back into the study as well. So just move me on, please, Phoenix. I just want to really spend a couple of moments just talking about hydrogen blends and their role in a transition, because it's not going to be very easy to go from 0 to 100%. There's a number of reasons for that. One is the physicality of actually doing it. How would you manage that? How would you measure it? How would you create a market mechanism to allow you to do that? You've also got to work out how on earth you would produce that much hydrogen to get to that point. So I think it's entirely reasonable to think that we will start with low levels of blend and work our way up. So I have a view here that we've probably got two very distinct areas. You've got the low level blend area, which is on the left-hand side of the screen. And for me, that's very much 0 to 20%, 2 to 20%, low levels of blend up to sort of that domestic limit of 20%, where you can facilitate hydrogen production getting started, particularly in a UK context where we've got industrial clusters, they're supporting industry, but they also want to be able to get gas away as part of their business model and get gas into their networks. So we can very quickly accommodate very, very low levels of hydrogen blend into our networks, and it allows transmission and distribution to benefit. It is, however, a very limited carbon benefit. 20% hydrogen will give you about a 6 to 7% carbon benefit. So it's worth having, but it's not the end game. And that's really where trying to get to a backbone as quickly as you can, where you've got 100%, and then distribution getting up to 100% as soon as you can, really helps. And I've really shown the top end of that graph there as what I've called high quality hydrogen. But you'll notice I use a term there. Under H2 standard, I've used a term I've called network quality hydrogen. So we're working on the quality of hydrogen to be in our networks at about 98%. Obviously, you would ideally be at 100%. That's kind of unrealistic. If you could get 100%, you'd be able to run fuel cells in vehicles and so on. but we've got a legacy network. The moment you put 100% pure green hydrogen into our network, you're going to pick up contaminants. It's no longer going to be pure, and it's not going to be able to be suitable for transport purposes and fuel cell purposes unless you scrub that gas again. So think about high quality hydrogen being in that 98 to 100% range. That is perfectly suitable for burners, boilers, and most heat applications. And it's really, how do we get from that bottom end to that top end as quickly as we can? And it really is through that staged conversion, beginning with that backbone concept, but then a staged conversion as we move from transmission to distribution over a period of time. In that interim process, I think we're going to need a technology which I call hydrogen deblending. Other people would call it gas separation. So if you have got a blend of hydrogen in the network and you want to take it back out, using one of the gas separation techniques, such as cryogenics or pressure swing, or I think probably more membranes are going to be the way in which to provide a level of protection to sensitive customers in the network overall. So a lot to be done in this space. We don't have all the answers on the role of blending and how much and when. This is very much work in progress. But I'm hoping that was quite useful just to give you that sort of view that we've currently got about how we might support from transmission and distribution and move from those low levels of blend all the way up to those high levels at a later date. So just a few conclusions on the final slide, please, Phoenix, and I'll then open up to questions. So some very high level conclusions here. We think hydrogen's got a big role to play in industry, in the future of heat, and potentially in transport, particularly in heavy goods and fleet type vehicles. Hydrogen seems to have a really good role in that area. How much remains to be seen, and obviously electrification is one of the other big drivers, and the cost equation will ultimately come into it. We think the repurposing is looking possible. I'm very encouraged. We haven't found any showstoppers yet, nor of any of our TSO colleagues that we interact with. I still think there's quite a lot of evidence to be built, and that's one of the reasons that we're focusing on Future Grid. That project is almost £13 million on its own. This isn't cheap. It's very expensive research that we're doing, but we feel we've done that evidence base of 3 years' work to get us to this point, and we now feel it's justified to start spending those bigger sums of money to really focus in on it. I'll repeat my appeal at the start that actually collaboration is absolutely key here. That collaboration operates on a whole range of levels here. So if you are interested in what we're doing and you've got something you may be able to offer back to us, we're very interested in hearing. From the last meeting, I actually had a call and a follow-up with Zach, who's the final speaker today. So this event in the past has paid dividends to us to open up those communication channels. So overall, I think there's a massive opportunity on the hydrogen side. It's clearly got a role in the future of gas. We've really got to now prove it, demonstrate we can do this safely, and demonstrate we can do this economically as well. So with that, Phoenix, I'll wrap up and say thank you very much, and I'll take any questions anybody's got.
Thank you, Tony, for your presentation. And right, so because you don't have any poll questions,